Hello and welcome to another NGen Math 6 lesson by eMath Instruction. My name is Kirk Weiler and today we're going to be doing Unit 11, Lesson 1 on statistical questions. So Unit 11 is our unit in Math 6 on statistics. And statistics is an amazingly important branch of mathematics. It's huge. I mean, it's probably used in more areas than maybe any other sort of autonomous branch of math, all right? And yet, it's a very different type of math, not in terms of its calculations and numbers and things like that, but the type of questions that statistics seeks to answer are different than the types of questions that other branches of math try to answer. So today we're going to look at that. We're going to really dive into what kind of questions do you answer with statistics versus what kind of questions do you answer with other branches of mathematics, all right? So let's get into it right away. Here we go. Statistics is a branch of math that seeks to answer questions where variability affects the answer. Now, let's make sure that we understand what is variability, right? Variability is just the fact that when we measure a quality of a group, and whatever that group is, it's a bunch of people, it's a bunch of chickens, it's a bunch of automobiles, whatever, right? Those are called our subjects. But when we measure some quality of them, how heavy they are, how tall they are, how fast they are, how high they can jump, whatever it is, right? Height, color, speed, weight, income, etc. That the numbers aren't all the same for the different subjects, right? That's the whole idea. So, I mean, if we took a giant group, of people or whatever, and we measured something about them that was the same for every one of them, then there'd be no variability. Right? And it wouldn't honestly be very interesting, okay? But typically, when we measure a quality about a group, that there is differences in that quality amongst the group members. And those differences are what is known as variability. So just to make sure that we can kind of spot variability when it comes up, let's take a look at exercise number 1. In each scenario described below, circle the one in which variability is present. All right, this is pretty easy. Let's do the first one together and then have you do B and C on your own. So in letter A, we've got these two scenarios. The first one, Jenna bought $4.50 worth of candy at the movies. And the second scenario, Jenna has 4 friends who each spend money on candy at the movies, right? In which of those two scenarios is there actually variability? Well, it would be in this one, right? In this one, there's a single amount of money. There's a single subject, Jenna, and a single amount of money that she spent, $4.50. So if I just asked you, hey, how much money did Jenna buy, on candy at the movies, you'd be able to say $4.50, and there'd be no variability. That'd be it. On the other hand, if I said, hey, Jenna and her friends went to the movies, how much money did they spend on candy when they went there? Well, now there's variability, in all likelihood. Now, granted, maybe all of them spent exactly the same amount of money. That would be all by itself kind of interesting. But in all likelihood, right, some of Jenna's friends spent more, some of them spent less, right? There was differences in how much they spent. So what I'd like you to do now is I'd like you to look at the two other scenarios, and again, there's always these two, right, and these two. Figure out which of the scenarios involve variability and circle those. All right, well, letter B, Max ran the 100-yard dash in 16 seconds. 8 people ran the 100-yard dash. Well, again, this one, there's going to be variability in there. There's no getting around that. There's no way those 8 people are going to run the 100-yard dash in exactly the same times. So, I mean, again, if the question was just, how fast did Max run the 100-yard dash? There's only one answer, 16 seconds. If, on the other hand, you had a race with 8 people and you said, how fast did those people run the 100-yard dash? There'd be variability going on there. Right? There'd be differences. You might say, well, the fastest person ran it in 14 seconds and the slowest person ran it in 17 seconds or something like that. Letter C, Nora's friends send various amounts of texts this week and Nora sends 18 texts this week. Well, again, not a great surprise. These are pretty easy to spot. Nora's friends send various amounts of texts this week. Again, think about this. If I just ask the question, how many texts did Nora send? The answer is 18. On the other hand, if I said, how many texts did Nora's friends send? Well, then, there'd be a range of answers. You might say, well, her best friend only sent this many, and her, you know, the friend that sent the least sent this many, and the average number that they spent was this many, or sent was this many, all right? Variability is what statistics is all about. The fact that when we gather data on a group of subjects, each data value, right, or not all the data values are the same. There is variation within the data. All right, this gets us into what is a statistical question. And I was already trying to get it in there, right? A statistical question is one that you answer using the branch of math called statistics. And it's specifically a question that anticipates that there will be variability in the answer. So let's take a look at exercise number 2. The Boston Marathon is a huge race that often has around 30,000 runners each year. 30,000 runners! In 2018, Desiree Linden won the women's portion of the race. Letter A. Given the question, how long did it take for Desiree Linden to run the Boston Marathon, explain why this is not a statistical question. Well, let's talk about this together, right? Desiree Linden wins the Boston Marathon in 2018. The question is, well, how long did it take for Desiree Linden to run the Boston Marathon? That's not a statistical question because there was only one, and that's key, there was only one time it took her, right? There was only one time that it took her to run that marathon. So that's not a statistical question. On the other hand, let's take a look at letter B. Given the question, how long did it take for runners to complete the 2018 Boston Marathon, explain why this is a statistical question. Well, again, imagine that you're somebody who's thinking about running the marathon. And you go out and maybe you run a bunch for half a year, and eventually you run a marathon and you get your time. And you think to yourself, I wonder if this time is reasonable. So you ask, well, how fast do people run the Boston Marathon, right? That is a statistical question because there are many different, that's not the word different. There are many different times that it took. Variation. Right? There's variation in the amount of time that it took, right? There's somebody who finished first, Desiree Linden, right, in 2018 for the women. There's somebody that finished last, right? There are the people that finished in the upper half, the people that finished in the lower half. There's average amount of time. There's all sorts of different amounts of time that it took for people to finish this race. And because of that, this is a statistical question. Now let's see if you can figure out the last one, letter C, on your own. Given the question, how long did it take the female winners of the Boston Marathon to finish the race since they first ran in 1966, is this a statistical question? Explain. All right, so I'd like you to pause the video now and decide whether this question, as phrased, is a statistical question, i.e. it anticipates that there's some variability in the results, or it's a non-statistical question. All right, pause the video now and see what you think. All right, well, here's the key. How long did it take the female winners of the Boston Marathon to finish the race since they first ran in 1966? Is this a statistical question? And the answer is yes, right? And the reason why is because there is variability. There is variability in the winning time of the female winner over the years, right? So There's some winner of the Boston Marathon who ran it in the fastest time, not just for that year, obviously for that year, otherwise they wouldn't have won, but kind of overall. There's also the slowest winner ever. There's probably the average time that it takes for a woman to win the Boston Marathon. I mean, you might even extend this question a little bit and say, geez, are the winners of the Boston Marathon faster than the winners of the New York City Marathon? Right? And again, that's a fantastic statistical question because sometimes the winners of the Boston Marathon will be faster than the New York Marathon and vice versa, right? There is variability in the data, right? Because since 1966, there have been lots of Boston Marathon winners that are women, right? And they all have different times. All right, let's keep going with this idea of a statistical question. All right, we can analyze the variation in a data set by using tables, graphs, and other statistical measures, right? And we're going to get into different statistical measures as this unit goes on. Today, we're basically just going to review a basic way of looking at the data, all right, and one very simplistic statistical measure. So let's bring up exercise 3 here and take a look. All right, Yasmin teaches 6th grade math to 25 students. She would like to answer the question, how many pets do students in my math class have? She asks each student to record how many pets they have and collects the following data. All right, explain in letter A why this is a statistical question. All right, pause the video now and see if you can write down why this is a statistical question. Specifically the question, how many pets do students in my math class have? Pause the video now. All right, well, you don't have to use any kind of fancy words like variability or variation or anything like that. You could simply say, not all the students have the same number of pets. Right, and that's important, because it's not so much about there being more than one student, right? Because you could say something like this. You could say, well, how many tires does a Ford truck have, right? There are lots of Ford trucks out there, right? But they all have 4 tires. Okay, there is no variability. That is not a statistical question, right? Even though there's more than one Ford truck out there, the question, how many tires does a Ford truck have, is not a statistical question because the answer is 4, right? On the other hand, when she asks the question, how many pets do students in my math class have? Well, that is a statistical question because not all the students have the same number of pets. The first one had 1, the second one had 3, the next one had 4, the next one had 3, etc., right? Now, letter B. Summarize the data in the table to the right. All right, so sometimes, unfortunately in statistics, we have to take a bunch of data and by hand summarize it in some kind of a table. Now, oftentimes these tables have a location for tally marks. Literally, I go something like this. 1 pet, 3 pets, 4 pets, 3 pets, 2 pets, right? Starts to sound weird after a while, right? So that's tally marks. And then once you've got all the tally marks, then you can kind of do your totals. What I'd like you to do is finish off tallying all the data like I've started, figure out your totals, how many kids had 0, how many kids had 1, how many kids had 2, etc. Pause the video now and take a few moments to do this. All right, well, let's do it. 5 pets. Hopefully I won't make a mistake here. Another 3, another 2, another 1, 0, 3, 4, 6 pets. Maybe they have fish. 9 pets, that's a lot of pets. 3, 5, 2, 0, 2, 1, 3, 6, 4, 3, and 2. All right. Once I've done all my tally marks, it's then easy enough to say, oh, I've got 2 kids that have 0 pets, 3 that have 1, 5 that have 2, 7 that have 3, 3 that have 4, 2 that have 5, 2 that have 6, 0 with 7, 0 with 8, and 1 person has 9 pets. Again, you never know. Maybe they have 3 hamsters and a fish tank. Who knows? You know what I mean? Depends on how you count your pets. All right, so we've got our table. And tables are nice, actually, because you could very easily look at this table and get a sense for the, quote, answer to this question. Now, side note, the answer to any statistical question isn't a single number, right? It typically isn't, right? If we wanted to answer the question, how many pets do people have in this class, you could say, well, the least number was 0. The greatest number was 9, right? And then we could even bring in the first of our statistical measures, letter C. Which category, number of pets, occurs the most often? This is known as the mode of the data set. Well, that's pretty easy, especially once we have it in this table form, because I just look at these totals and I go, oh, well, 7 people had 3 pets. So this, right, is the mode. The mode is the data point that shows up the most often. All right? It's a statistical measure. So in other words, if she was trying to answer this question, if Yasmin was trying to answer the question, how many pets do students in my math class have? You could say, well, more kids have 3 pets than any other number, right? So if you're somebody that's got 3 pets, then you're in that kind of mode category. All right. And finally, we like a lot of times in statistics to create visual representations of our data, right? Here, we can do that on what's known as a dot plot, okay? And a dot plot is literally just basically doing something like this. Oh, I've got 2 students that have 0, right? I've got 3 students that have 1, etc., right? And we're using the dots to literally represent the data points. How many zeros do we have? How many 1s do we have? How many 2s do we have? And that's easy to do once we have the table. It's also actually pretty easy to do if we've just got the raw data. What I'd like you to do is finish off this dot plot. All right, well, you have to excuse me because I got to keep going back and forth. But for 2 pets, we've got 5 students. 1, 2, 3, 4, 5. For 3 students, we had 7. I remember that one. That was our mode. 1, 2, 3, 4, 5. I got to go a little bit up here. 6, 7. You probably will as well. 4 pets, we had 3 students that had 4. Let's see, then we had 5. 2 people had 5 pets. 2 people had 6 pets. No people had 7 or 8, so I'm not going to put a dot above them. And 1 person had 9 pets. And what's beautiful about a graphical display of a data set is it really gives us a quick picture of what the, quote, answer to the statistical question is, right? Again, if you said, well, how many pets do students in my class have? Well, you can definitely see the mode, right? That's going to be the number that's got the most dots above it, right? 3 pets. And you can definitely see that, there's a lot of people that have got like 2 pets, 3 pets, 1, 4. Not very many people have a large number, and there's actually very few people that have no pets at all, right? The person that just, no, I've got no cats, no dogs, no fish, no birds, no snakes, no turtles, hamsters, whatever. All right. Let's answer this last question. Do more students have less than the mode number of pets or more than the mode number of pets? Justify your answer. All right, well, see if you can figure out the answer to this. All right, well, the mode number of pets, right, was 3. All right, so these are the people that have less, and these are the people that have more. So let's just add them up. right? So the ones that have less are the ones that have 0. And there were 2 of them. 1, there were 3 of them. 2, 1, 2, 3, 4, 5, there were 5 of them. And that's going to be 10 people, or 10 students. Now the ones that have more than the mode number of pets, well, that's going to be the ones that have 4. That's going to be 3 of them. 5, 2 of them. 6, 2 of them. And 9 of them for that 1, or 1 of them with 9. So that's going to be 5, 6, 7, 8. So simple enough. More have less than the mode. Now, that's not always the case. It's not universally the case that a data set even has a mode, all right? But it's pretty easy to answer this question, and that just means that, the answer would be that, to the larger statistical question, i.e. how many pets do my students have, well, it tends to be on the lower side of things, 0, 1, 2, or 3, right? There's a lot of them that have 0, 1, 2, or 3, and a lot less of them have 4 or more, right? Answers to statistical questions can be very, very complex, right? You're in 6th grade, right? It's going to be a long time before you have to go out and get a job. But even now, you might be thinking to yourself, maybe one day I want to write computer programs, maybe apps for phones, like games and things like that. And you might want to know the answer, how much does one of those kind of people make? What's their salary? That's a great example of a statistical question, right? Because there are tons of people who write programs for phones and computers and things like that, and they get paid all sorts of different amounts, right? So maybe you want to know, what is the mode amount? What's the one amount that gets paid more than any other one? Maybe you want to know what the average is or the median. All of these we're going to talk about in the next lesson, okay? These are situations where you can't just give a simple answer to a question. The question, a statistical question, one that anticipates that there's going to be variability in the data set, right, often takes more than just a single number to answer it. And we're going to get into how we answer statistical questions in the lessons of this unit. For now, I just want to thank you for joining me for another NGen Math 6 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.